Entonces, se oiga, creo que sí. Pues, según yo sí. Ok, está bien. Okay, okay, good. Okay, let's see. We continue with what we were saying. Well, we are going to make a review, so you have it also like all the week, all the review of the week. So let's see it. Okay, remember that we were seeing, right, the 3 Newton laws, right? The 3 Newton laws were really easy. Remember that the 3 Newton laws were about, well, the first one is the inertia law, right? The inertia law is about the inertia, right? The inertia, remember that the videos that I put you, right, were okay, where remember that basically says that an object is going to maintain its velocity unless there is a resulting force different from zero, right? Acting to the object. This means, for example, some examples is when we are driving, right? When we put the brake, right? The car stops, but we don't have any force that is stopping us. That's why, like, we need the seat belt, right? That's why we need the airbags in order to stop us, right, from going out from the car, right? That's thanks to, well, that's the force that we need in order to stop our velocity. Also, the inertia is the one that allows us, for example, to walk inside a bus, right? Remember that that is the one that allows also the same in the airplane, right? As I have put you like a lot of time, let's put it again, but the Malcolm in, right? Do you remember that, for example, Malcolm, it says about the velocity of the air, right? That's why we see that a tree, you know, a building, something like that, is like at rest, the velocity is equal to zero, but that's for us because if someone sees from Mars, right, they are going to say that it's moving because remember that we already have the same velocity of the Earth, that's why we don't feel it. But like if it starts accelerating, we will feel it, right? Remember that what we feel is basically the acceleration. That thanks also to the inertia law. Okay, let's see. Okay. Okay, just for you to remember really fast. Okay.
Profe, ¿le puedo compartir pantallas? Que tenía una duda rapidísima. Entonces,
Okay, good. Right? Remember, yes.
De la Tierra. Un cohete debe alcanzar velocidades más de 40.000 kilómetros por hora. Mentira. Si fueran tan rápido que hayan aplastado contra sus asientos, y además nos lograrían. Estás cumpliendo aceleración con velocidad. La gente viaja con detrás del bando, pero la canción de velocidad no lo notas. Ahora mismo estamos en un planeta que a 1.600 kilómetros por hora. Y es con la velocidad de rotación también ponemos eso a las 110 kilómetros por hora. Y además el sistema solar corre por toda la galaxia que se está alejando de todas las galaxias porque el universo se expande.
Okay, right? Okay, basically it's that the first Newton law, the inertia, right? Okay, as I have shown you, right, some example like the right when we stop, when we are walking inside a bus or an airplane, right? That's the inertia, right? The first Newton law. Okay, the second Newton law is really easy. Yeah, Mariano.
¿no se escucha?
Yes, yes, yes.
Ah, que si le podía compartir rápido la pantalla, es que tenía una duda, tenía un problema.
¿Cuál? Ah, ya, ya. Okay. Okay.
Hola, ¿qué tal? Escuchando un poquito de cumbia, dejarte las felicidades y desearte lo mejor, hermano. Que vaya todo bien y que disfrutes de la vida. Un abrazo, hermano, número uno.
Gracias, gracias, chavos.
Felicidades.
Gracias, chavos, gracias. Gracias.
¿Cuánto cumple? ¿Cuánto cumple?
El 25, ya, 25
Ay,
años.
Jesús.
Y ya bastante, 25. Gracias, el bicho, el mejor.
Bicho.
Gracias. Gracias.
Seguimos personalmente.
Sí, gracias. Sí, ¿qué más les iba a decir, chavos? Bueno, va, gracias. Pues ya ni modo, a lo mejor el lunes, pues les llevo lo que se iba a llevar una pizza, pero pues ya, ni modo, ¿no? No, el lunes será. Sí, sí, pues ya ven, por la lluvia, exactamente. ¿Qué? Ah, sí. Gracias, chavos. Ahí. Excelente. Pues muy bien. Y miren, hablando de la lluvia, vamos para la segunda ley de Newton. Okay, first second Newton law, right? Okay, good. The second Newton law, right? It says that what is guys? Yeah. The second Newton law, guys, says that the it's just a formula, right? The force is equal to mass times acceleration, right? The A is the acceleration, right? And the M, right, is the mass. Good. That's really important, right? And remember that the force, the unit is the Newton, right? Of acceleration is meters per second square, right? Okay, good. And mass is kilogram, right? Okay. Remember that I told you that people for architecture, and mechanical engineering, civil engineering, and robotics and physics is really important. This. Remember that we have the equilibrium, right? The equilibrium is when we have a static, that is when the velocity is equal to 0, right? And dynamic when the velocity is constant, right? Good. Okay. Then this is right. Remember that, well, talking about the rain, right? That's why we are not in the classroom, right? That's the dynamic equilibrium, guys. Remember that this drop of water, right? It has the weight, right? That the weight is the force due to the gravity to any object, right? Inside the earth, okay? In here, this is falling, but remember that there is an air resistance, right? Okay, so these ones make equal to 0, right? This the sum of these two forces is equal to 0, right? So it will continue with the same velocity because that's from the first Newton law, right? That is going to continue with the same velocity. So, okay, it's going to continue with the same velocity, right? That is 7 meters per second. That's because that process of stopping the drop of water is not like instantly, right? It has like some time, really small, but it still has time, right? In order to get that velocity. But it's going to be a constant velocity of 7 meters per second until it falls, right? That's what happens with rain, like yesterday, right? That it rained a lot. So basically that's what happens. That's the first and second Newton law combined, right? And well, remember that we had, right, the equilibrium is where the sum of the forces is equal to 0, right? It's where the sum of the forces is equal to 0. So we have that force 1 plus force 2 plus force 3, right? Plus force n, it means that you can have n forces. That means that you can have 1, 2, 3, 1 million, 100 million, whichever number of forces that the system has, right? The important thing is that for something to be in equilibrium, it should be equal to 0, right? Okay, good. Equilibrium, remember that we are in a three-dimensional universe. So this means that in order to be something in equilibrium, we need that the three dimensions are in equilibrium, right? X, Y, and Z, right? Good? Okay. And well, we also have some things that are dynamic, right? Yes, in fact, they have an acceleration. That basically is the sum of all the forces, right? The sum of all the forces is equal to the total mass. The total mass is basically la suma de todas las masas, ¿no? Okay, good. And the sum of all the masses, right? And the acceleration, right, of the system. Remember that I told you that a system should have always the same acceleration, right? Because they are joined together. Okay, good. So, right, that's basically the second Newton law. Massa por aceleración. Mass times acceleration, right? One of the most important and most famous formulas, like in everything, is the second Newton law. Okay, good. Okay, and well, we also have the third Newton law, right? The third Newton law, it says to any action, there is a reaction, right? So some examples, remember that is swimming. For example, ahorita que lo pusieron, ¿no? Cristiano Ronaldo, right? Like when he jumps, right? And scores the goals, right? Or the head goals, right? He uses a lot the third Newton law, right? Because exactly like he uses, right? The power of his feet, right? In order to, okay, vamos a poner. Okay, good. Cristiano Ronaldo, CR7, Juventus. Okay, good. Okay. Remember, third Newton law, it's Cristiano Ronaldo.
And this is one of the benefits.
That's the third Newton law, right? Okay, that's the third Newton law, guys. Like, see that jump, a ver si lo ponen en cámara lenta. That is the third Newton law, guys. Like, when he jumps, right, he uses a lot that, right? Okay, that's perfect example of the third Newton law. El comandante, right? Good. So, okay, good. Okay, well, like swimming, also Michael Phelps, or que se les ocurra, right? Like pushing a wall, like remember that also that's really important. That's going to be really important for our problems, right? In this subject, because we have the normal force. Remember that the normal force, for example, right? It was like the Squid Game, right? Remember the Squid Game, the scene, right? Okay, let's put it also. Okay, I just have it in here. So okay. Okay, wait. Remember from Squid Game, right? Like if the floor it doesn't have the enough mechanical resistance to generate the normal force, that's what's going to happen, right? Okay, in there, yes, remember that well the gas, right? The bridge, it has the force, right? Enough to make it to well, yes, no, not to fall, right? It can generate the normal force, remember? In there, no. In there, in the gas, right? As it was not tempered, it was normal gas. It didn't have the enough force, right, to generate the normal force that it will cancel its weight, right, his weight, and that's why he starts falling, right, because there is no equilibrium. Okay, remember that when there is no equilibrium, guys, is when it happens the acceleration. Okay, good. Let's continue. Let's continue. Okay, right? Okay, the turbine, the takeoff of a spaceship, swimming like that, right? Okay. Remember that the third Newton law basically says that always that you apply a force, right, to an object, this object will return you, right, the force, right, with the same magnitude but opposite direction, right? Okay, basically that's what it says the third Newton law. We have many examples. Okay, right? Let's continue. Okay, the weight, guys. The weight basically is the force due to the gravity. It has a name, right? This is going to be for sure a question in your exams, right? They are going to ask you like if you have the same weight here and in Mars, something like that, or in the moon, right? If you remember the video, right, of the girl that she says, she said that there was no what? Well, yeah, there was no gravity on Earth, right? That's not true. Sorry, in the moon. She said that there is no gravity in the moon. That's false, right? There is gravity, it's lower than in here, but you are still covered, right? That's why in the moon you weigh less, right? Okay, good. What else? What else, guys? Okay, good. Okay, what else, guys? Okay, yeah. Remember the weight, right? The weight is different in every planet, but the mass is universal, right? It's a universal property of the matter, right? The mass of the object is the same in any part of the universe, right? The mass, the weight, no. The weight is a force, the mass is a property of the matter, right? Okay, remember that there are two types of forces, right? The contact and the distance. The contact forces, remember that's when the two objects are like in contact, right? The distance is when they are not. For example, distance forces, it can be like gravity, it can be like magnetism. If you remember also from, well, let me put it also. Okay. Breaking back. Okay, good. Right?
¿Deseas transformar un texto?
Okay, wait. Okay, good. Let me put it really fast. Okay. Okay, good. Right. Okay. Right, remember this is like a distance force, right? The magnetism is an example of that, right? That basically the things are moving, right? And they are not like touching the magnet. So basically it's like that. It's like the gravity. We are not in contact with the center of the earth, right? So but still it attracts us. Okay, good. Okay, guys. So the free body diagram, right? The normal force, right? The remember well that in all these problems, right, of forces, right, we are going to have something that is called the free body diagram. As I have told you before, right, the the forces, right, the when we have problem of forces, we have to do a free body diagram, and the same name says half of the answer. Body diagram. Diagram is a drawing, right? Un dibujo. Y body es cuerpo, ¿no? O sea, it means that if we have 5 bodies, we need to draw 5 diagrams. For each body, we need to draw all the forces that are affecting this object, right? Good. For example, remember that always that we are on the earth and this is in the ground, right? We are going to have the weight, right? And this, as this object is not falling, as it is not flying, right? As it is not falling, it's then because this weight should be, right, equal. Well, there should be another force, right, that cancels the weight. That force is called the normal force. That remember, the normal force is the force that is generated by the ground. Is the one that stops us right now. If you are sitting right in a chair, then the chair is resisting the weight of you. That's why I don't know if you have seen like all the Spider-Man movies when this Doc Ock, right, this octopus, right, when him like that's something really funny because when he like carries like something with like his 4 arms, right, his 4 mechanical arms, right, and he lifts a car or he lifts a structure, right, of metal, that will be not possible because if you do that, all the weight that he is lifting lo tendría que cargar en sus piernas, en su columna. Entonces lo que pasaría, like all his spine, right, all his legs will have to resist like tons. So it will have to resist a lot of weight and that will, well, kill him, right? So that's not true. The only way that he could do that is like if 2 of his arms are like in the ground, right? Y los que estén cargando are his mechanical arms and not his legs. Because if he uses 4 of his legs or if he uses, like, if there is not the force made by the arms and it's made by his legs or his spine, he will die. But okay. Basically, that's something that is not realistic. Well, Spider-Man, generally not realistic, but that thing of physics is definitely not realistic. So, if you someday invent some mechanical arms, remember, don't use the force to try to lift something because at the end you will have to lift all that weight in your spine. Okay, good. Okay, so right, and the example number 2, remember that we had, for example, this mass, right, that is is receiving a force of 10 newtons to the right. Okay, remember guys, always the first step is to do the free body diagram. The free body diagram is just to do all the forces that are affecting this system. This system is affected by 3 forces: the normal force, the weight, and this force. Okay, remember that. Okay, in here we have a 2-dimensional problem because we have in x and in y and x. Good. The sum of the forces in x, we just have 1 force, so it's going to be 10 newtons. Remember the second Newton law, guys. This one, right? The second Newton law, one of the most important, most famous formulas like in all the world, right, is this one. Force is equal mass times acceleration, right? Okay, we have a force of 10 newtons, a force of 10 newtons, right? We have a mass of 10 kilograms, a mass of 10 kilograms, right? So in order for us to get the acceleration, right, of the system, it's going to be really easy. We just have to isolate, despejar, ¿verdad? 10 kilograms go to the other side. This one is multiplying, we pass it to the other side dividing. So we have 10 newtons divided by 10 kilograms. That's going to give us 1 meters per second square, right? Good. Okay, and that's the acceleration in x. They are also asking us the normal force. It's really easy. The normal force minus the weight should be equal to 0. The weight is just the formula, right? Mass times G, right? Okay, 10 times 9.81, 98.1 newtons, right? This one is subtracting, we have it minus 98.1. We pass it to the other side, how? Adding, right? That's why the normal force is like this, and it's positive and it's logic, right? Because the normal force always points down, always points with a 90 degrees, right? Of the ground. O sea, apunta hacia arriba, en este caso, right? Good? Okay. So basically, it's like that. Let's see the example number 3, right? Example number 3, guys, basically it says the following, right? The the normal force, right? We have this object that is being pulled by this person, right? With a 100 newtons with an angle of 35 degrees, and this generates an acceleration of 1 meter per second squared to the right in the x direction, right? Good. So we have 3 forces, this one, and this one. This force has an angle, so we can translate it to its components, right? The force in x and the force in y, right? Okay, good. So remember the first step is to do the free body diagram. The second step is to put the equations of the forces. As we have 2 dimensions, guys, we are going to use, right, 2 equations. The force of the x, right, and the forces in y, right? As this object is not falling and as it is not falling, right? O sea, como no está ni volando ni cayéndose, pues entonces la suma de las fuerzas should be equal to 0, right? Good. In y. In x, it is moving because they are telling us that we have an acceleration of 1 meter per second squared, right? Okay, good. So let's see. In x, we have, right, that is going to be dynamic. Dynamic, remember, is the second Newton law. The sum of the forces should be equal to mass times acceleration in x, right? Because this is in x, okay. The force of the person in x, right? That is the only force that we have in x. That is the component of this force, right? We can get really easy. It's just the cosine of 35 multiplied, right, by 100. We have it that where look hasta abajo, good. Yes. We have it there, right? And it's here. We have it here. Okay. Right? Okay. The force of the person in x is 100 newton multiplied by the cosine, right, of 35, right? This is this part of the equation. The mass, right, we don't have it yet, but we have the acceleration in x because they gave it, right? We have the acceleration. Okay, we want to get the mass of the object. We need to isolate, guys. Okay, this one is multiplying. How do we pass it to the other side? Dividing. So we have that 100 newtons multiplied by cosine of 35 is 81.92 newtons. 81.92 newtons divided by 1, right, is going to be equal to 81.92 kilograms. 81.92 divided by 1 is the same, but okay, newtons divided by meter per second squared is going to give us kilograms, right? Because that's the unit for mass. Good? Okay, now that we have the mass of the object, now that we calculate, we can get the weight. Okay, the mass of the object is 81.92, right? Multiplied by G, right, by the gravity. And that's going to give us, if you do it in your calculator, it's going to give us this. Okay, this, right? And the weight, well, the force of the person in Y is really easy to calculate. The force of the person in Y is equal to the magnitude 100 newtons multiplied by the sine of the angle, 35 degrees, right? 35 degrees. Good. Okay, so we do it, right? And we get that that's going to be 57.36. This 57.36, we add it to the weight. Remember that the weight is pointing down, so it should be negative, right? And that's going to give us like minus 746.231. Normal force equal to 0. This one is subtracting, we pass it to the other side, adding, right? So we pass this one and this one finishes being positive. And that's what we have here. And we solve our problem. Good. Okay, let's continue. You have everything like recorded. You can see it later, like slower, right? but so you can have everything recorded. How do you do each, right? Each problem. In here, really easy, guys. You have like these two, right? These two ropes. O sea, tienen estas dos cuerdas, ¿no? Que están colgando y está una masa, ¿verdad? O sea, tenemos tres cuerdas, que es la tensión 1, la tensión 2 y la tensión 3. Okay. Tension 1, tension 2, and tension 2, right? In here, they are not giving us the angle that we are used to use, right? The direct one. So we need to get them, right? In order to get them, we have to remember something about Math 4, or like in secondary school also, that is, right, los ángulos internos y externos. Good? So, okay, guys, because in here, if you see, this is parallel lines, right? And remember, this angle is equal to this, it's equal to this, equal to this. Remember that the sum of these angles should be equal to 180. This is important because so the sum of this should be equal to 180. 180 minus 130 is going to be 50. So this angle is going to be 50, right? And this angle is the same as this one, that is one of the ones that we are looking. So the angle of T2 is going to be 50, and we put it like that, right? Good. Okay. The second angle, this angle that we want to know, right, is going to be equal to this. The same, 180 minus 40, right, that they are telling us this is 40. That's going to be 140. 140 is same, is the same that in here. That's the angle for T1, that is this. Okay, good. The angle of T3 is the angle that it gets this. This is 90, this is 180, this is 270. Good. We have the three angles. Excellent. Now remember that we have to do like the both equations. Okay, remember that the sum of the forces in X is equal to 0. The sum of the forces in Y is equal to 0, right? Good. Okay. Then remember that, okay, for getting the X component, right, we can get it like multiplying the magnitude multiplied by the cosine, right? Okay, we use it for each of the forces, right? You have three forces, and each force can have its X and Y components, right? Good. So we do it, right? We start calculating the cosine of angle T1, angle of T2. Angle T1 is 140. That's why we have cosine of 140, right? Okay, the cosine of angle 2, cosine of 50, that this is 50, right? And we do it for each of them, right? And okay, then the T3, remember, this T3 we can see that is going to be equal to the weight of this mass. It's going to be 10 kilograms, right? 10 kilograms, remember the formula of the weight is mass G, right? Mass times the acceleration, right? 10 times 9.81, right? That's going to be 98.1 newtons, guys, right? Good. Okay. And when we substitute everything, we are going to finish having this pair of equations, these two equations, right? Okay, these two equations, guys, remember that what is that? It's a system of linear equations. We have two equations, right? Equation number 1, equation number 2, right? And we have two unknowns, unknown 1, unknown 2, right? We want to determine them. So we use any of the four methods that you have already seen, right, in secondary school and in Math 2, right? That is basically substitution, elimination, evaluation, or graphical. We use in here substitution. Substitution, guys, is really simple. You, for example, choose the first equation. Okay, and you choose that you want to determine, well, you want to isolate T1. We are going to isolate T1. Okay, good. This one is adding, guys. How do we pass it to the other side? Subtracting, right? Like this. Okay, this one is multiplying. How do we pass it to the other side? Dividing. As simple as that. Okay, this one divided by this one is going to give us T1 is equal to that. Okay, good. Okay, this one, right? We know that T1 is equivalent to that. So we can do the following, right? This T1, right? We are going to substitute it. Remember, that's why it's the name, right? Substitution. O sea, lo vamos a sustituir, pues se llama así, right? In here. So we are going to replace the T1, right? For this. Okay, that is what we are doing in here. This one is multiplying this. And if you put it in your calculator, this multiplied by this is going to give you this. Okay, this and cross this, right, we are in the same variable. El punto de sustitución es dejarlo todo en la misma variable, in just one variable, right? And here we have it, right? It's the same variable. So we can add them. We can add the coefficients. We add the coefficients in the calculator, okay? And we have that that's equal to 98.1, right? Because, well, same. This was subtracting. How do we pass it to the other side? Adding, right? Good. Okay. This 1.305, right, is multiplying the T2. How do we pass it to the other side? Dividing. Okay. You have this divided by this, right? And you're going to get that T2 is equal to that, guys. Okay. This, guys, okay, the same. That's why it's called substitution, right? You are going to replace it, right? For example, in here, you replace it in here, and this T2 is equal to this, and it's going to be just multiplying the 0.8391 multiplied by the 75.149, and that's going to give us that the T1 is equal to this. Right? Good? Okay, let's see. Okay, the plano inclinado, right? Okay, let's see it again, right? Okay, remember that in here, okay, they are going to, let's see the system before. Okay, we have a mass of 20 kilograms on the right, that it has a velocity of 0 meters per second, so it's static. Okay, we have a tension of a rope that is stopping, right, that object from moving. Okay, good. So let's see, we are going to have, as always, the weight, right? Let's always point down. We're going to have the normal force that always, remember, is perpendicular, right? So this is going to be perpendicular, and we have the tension, right? Good. We have these three forces. In el plano inclinado, what we do is to rotate our axis, right? We're going to rotate it. And remember that this is important because we are not going to use this angle, right? Okay, we can use that angle, but if we use that angle, remember that we have to invert. So if we use the 50, right? We, instead of using for x the cosine, we are going to use sine, right? And instead of y using the sine, we are going to use cosine. That if we use the 50, guys. Okay, if we use the angle that they are giving us, right? Why? Because remember that that's the angle, que es el ángulo que está pegado al eje Y. And the one that we normally use is the ones that are close to the x-axis, right? So, como lo invertimos, ¿verdad? Como ya estamos usando el que está pegado al eje X, usamos el que está pegado al eje Y, pues entonces se invierten las funciones trigonométricas. But in order not to do that, right, we can have another method, right? That is basically the 90 minus this angle. This, because, okay, guys, the logic is like this. This is 90, right? This is 50, and that the sum of them should be 180. The sum of this angle and this angle should be equal to 90. So if we get 90 minus 50, we're going to use 40, que es el ángulo complemento, ¿no? Que es el que falta para llegar a 90, right? So this one, right, we can use it, and if we use this one, we can use the normal ones, o sea, podemos usar de que para X coseno y para Y seno, as always, right? Business as usual, right? X for cosine and Y for sine, right? We use it like this, I use it like this in here. Remember that the weight is equal to mass times G. The mass is 20 kilograms, the G is 9.81. We get that the weight is this, and we're going to get the X and Y component, right, of the weight as we have it in here. Okay, this is the X component, right, that is going to be multiplied the cosine of the 40, not 50, not 50, 40, right, that we got it here. Okay, multiply by the weight, and that's going to give us the WX. WY, the component Y of the weight, right, is going to be equal to the sine of 40 multiplied by the W, right? And okay, guys, in here, right, it will be just really simple. O sea, ya que tenemos estos valores, los ponemos cada quien en sus ecuaciones, ¿no? And we are going to isolate, and we are going to get these values, right? Okay? And well, just to see the last one, right, of dynamics, right? Remember, all that previous, it was when we have that it was static, that the acceleration it was equal to 0. In dynamics, it's the opposite. We have to have that the acceleration is different from 0, right? Okay, for example, in here we have a problem where we have three people, right, in an elevator, right? And this has a motor, right, that it has a rope that is generating a force, right, that it makes that this elevator has an acceleration of 2 meters per second squared, right? Okay, so in order to do that, right, we need to calculate how many forces we have. We have the 3 weights, right? And we have, right, the weight of the elevator, and we have the force of the motor, right? Okay, so we add, right, the weight of these 3 people, right, plus the weight of the elevator, and we have to, these ones are pointing down, right? The force of the motor is pointing up. The force of the motor should be greater than the force, well, the weights, right? Because it wins them and it also generates this acceleration. So we have that the force of some of the forces in Y is equal to the mass, total mass times acceleration. This is just the second Newton law. The total mass is just adding all the masses. We have 3 people that has a mass of 70, so it's 70 plus 70 plus 70, plus the elevator has a mass of 1.5 tons, 1,500 kilograms, right? So we have that the total mass is going to be this, you put in your calculator, right? Good? Okay, we have this one, the sum of the forces in Y. The sum of the forces in Y is going to be all the 3 weights of the people, the weight of the elevator, they are pointing down. That's why this is negative, right? Plus the force of the motor. The force of the motor is going up. That's why this one is positive. Okay, we want to isolate this. So we pass all of this to the other side, adding, because it was subtracting, like this, right? And times the mass of total and times the acceleration. We have the acceleration is 2. We have that the total mass is 1,710, right, kilograms. And okay, if you do this multiplication, right, and you add these ones, right, you're going to get this. That the force of the motor is this. If you don't believe me, just give me 1 minute. I did it in the calculator already. And okay, let me just show you really fast, so you can go. Okay. I think this is good. Okay, well, this was the calculation. It was this, right? Okay, this, and you get this. Okay, this is the masses, right? This is the acceleration. This is the weights, right? Okay, and that's it. When you do it, that's going to be the total force that it needs the motor in order to get that movement. Okay, guys? Well, I think that's it for today. And okay, good. Okay, okay, see you.
Gracias, profe. Felicidades.
Gracias, chavos.
Gracias, profe, que se la
Gracias,
pase bien.
profe. Que la
Gracias.
pase bien, profe.